Good morning. My name is Liz Ward. It's nice to see you guys here. We have a rare treat today because Chris Giersch works for the agency, not just for NASA, Langley, and he's going to share what he's doing in preparation to cover the 2017 solar eclipse that takes place on August 21st. And he's going to cover it from the agency perspective, right, Chris? Oh, okay, good. So I would like to know, first of all, because this is an AIAA-sponsored seminar along with Aeronautics Research Directorate, can you raise your hands like this if you're an AIAA member, either here or somewhere else? Put them up higher so people can see it, because I've got somebody counting in the back. Keep them up till, are you done? Okay, got them, thank you. So this is a joint enterprise. We have this seminar this morning, and then at 2 o'clock this afternoon, we have one about the Game-Changing Technology Program, which is also an agency program. And the speaker will be Mary Beth Wusk, who's the acting director for the Game-Changing Program. So I hope you come back to hear that. Game-Changing Technology is one of the newest programs at the agency, and we have at least one representative from that program here. Kevin? Anybody else from Game-Changing here? No students? Wow, okay. Oh, yeah, all right. Okay, so I'm going to give it to Chris, and he's going to tell you a little bit about his career, and I invite you back to come back at 2 o'clock to hear Mary Beth, and thank you, Chris.
How you guys doing? Good morning. That's great to be here. Thanks, Liz, and my name is Chris Giersch. I am the Communications and Education Lead for STED, which is the Space Technology and Exploration Directorate. Been here at NASA since 1999, somewhere in that time frame, and I was a high school math and science teacher before that. What we're going to talk about today is a very exciting astronomical event that's going to take place on August 21st, and that's going to be the total solar eclipse. But before we actually get into it, let me tell you a little bit of background about how we're going to cover it, what we're all about. We do a program here for the agency based here at Langley, but we do it for the whole agency called NASA Edge. Anyone ever heard of NASA Edge? All hands should be going up. All hands should be going up. Just put them up anyway. NASA Edge, yeah, there we go, good. Okay, so NASA Edge is a very cool video podcast that we've been around for 10 years. This is our 10th anniversary. We've produced over 150 shows, at all 10 NASA field centers. We even traveled internationally, covering the different NASA events. And this event here coming up on August 21st is probably going to be the biggest event that we've ever covered in our 10 years. And we've done some pretty big ones, from shuttle launches to Venus transit to the landing of Curiosity to a number of different missions. But this one right here is going to push our limits technically. It's going to push our limits from a show perspective. It's going to push our limits from an excitement perspective. So hopefully by the end of this presentation, you'll kind of get an idea of what we're going to be doing on that day. And we'll tell you where we're going to be. So NASA Edge, so you've got a homework assignment for all the students, not the workers, but the students here, you have a homework assignment. So what you got to do by next week, we'll give you Monday. We'll give you until Monday. You've got to download all 150 plus shows. All right? And watch it. Well, that's a bonus. So you got to watch them. So I mean, yeah, that's good. You got to watch them. Don't watch them all in one week. Download them. Okay. So you go to our website. Write this down: www.nasa.gov/NASAEdge. Real easy to remember. NASA.gov/NASAEdge. Also, if you are a member of iTunes, you can download the shows from iTunes. We're also on YouTube. We have a Facebook page, Twitter, which we'll talk about later. So download the shows. I want you to become a member of the. If you're on Facebook, become a fan of our page, and if you're on Twitter, I want you to follow us, because I guarantee you, August 21st, the Twitters are going to be rocking that day, all right, and even leading up to that event. So please take part in that. All right, August 21st, 2017. Where are you going to be on August 21st? Tennessee, watching the eclipse. Where else? Where else? South Carolina. Columbia, Missouri. Idaho. Idaho Falls? Yeah, where else? Where are you going to be? South Dakota. Wyoming. Wherever the weather is, that's right. That's a good call. And if you're an eclipse chaser, that's pretty much what you're going to be doing. You're going to be sort of deciding at the last second where those clear skies are going to be. We're going to be in Carbondale, Illinois, at Southern Illinois University. That's where our target is. That's where our show is. And we're going to talk a little bit more about that in a second. So, the total solar eclipse. The great thing about this event right here, even though this path here is called the path of totality, that's where we're going to have complete 100% blockage of the sun. So the moon's disk is going to cross, the moon's going to cross between the earth and the sun. It's going to block the sun, and it's going to appear as if it's nighttime. However, the cool thing about this total solar eclipse is the entire country will see a partial eclipse. That's the beauty of it. That's why everyone can take part in this event come August 21st in this country. Here in Hampton Roads, we're going to have about an 87% blockage. Not complete totality, but that's pretty close. The only bad thing about it is, if you're not in totality, of course, you're not going to be able to see the corona of the sun with the naked eye. You're going to have to use, if you're in a partial zone, you're going to have to use special glasses and viewing devices, which we'll talk about. All right? So on August 21st, what's going to happen is we're going to have the sun, or I mean the moon, this eclipse is going to start off on the west coast, work its way across Oregon, through Idaho, where Kevin's going to be. He's got a nice advantage point come August 21st, into Wyoming, Nebraska. Yes, Iowa's got a very tiny sliver. Same with Kansas, into Missouri, Illinois, Kentucky, Tennessee, North Carolina, Georgia, and South Carolina. If you're going to be in any one of those states in that path, you're in luck. And of course, it continues on into the Atlantic Ocean. Now, if you go state by state, this is where the cool part of the event happens. So NASA is going to be covering this event, and I got to say, there's hundreds and hundreds of different locations across the country that NASA is going to be located for this event. We're just not picking a few spots. We've got multiple spots in each of those states that are within the path of totality. NASA is going to be at places outside the path of totality. I mean, the STEM outreach is going to be enormous on that day, and even the weekend leading up to that Monday. Who's going to be in Oregon again? Raise your hand. Who's going to be in Oregon? Anybody? Okay, that's not bad if you're going to be in Oregon, because if you're along the coast, if you look at cloud data over the past 10 years, it's going to tell you there's a good chance it's going to be cloudy that day. So that's good that you're not going to be along the coast, all right? So the first point of contact for NASA here on Earth is they're actually going to fly a WB-57 along the coast out in the Pacific Ocean, and that's going to be the first images that we're going to see of the eclipse from the WB-57. That's going to actually be pretty cool. In fact, the AA for the Science Mission Directorate for the agency will be on that plane taking some cool shots. NASA Ames Research Center, which is, of course, located in California, they're going to be in Salem, Oregon. That's their highlight. They're going to be there broadcasting live as part of the main NASA broadcast. Exploratorium, which is a huge partner for the agency for NASA Goddard, they're going to be in Madras, Oregon. And we actually have a scientist that we interviewed for the show. His team is going to be in Madras, actually doing scientific studies of the lower corona during totality. He's going to be bringing his 2 or 3 telescopes. He's got all his gear. He's going to be living in elementary school for the weekend. So the principal has given him an entire classroom. You can sleep. You can set your equipment up there. That's all yours for the weekend. So that's what they're doing to save some money. We move on from Oregon. We go into Idaho. So Kevin's going to be in Idaho. So NASA Jet Propulsion Laboratory is going to be in Idaho Falls. Idaho Falls, Idaho. It's going to be another location where we're going to be streaming live from that state. Kevin, you're going to be around there? Or Okay. Just make sure you're within that path that day, yeah. All right. Idaho's a great spot. The chances of having clear skies are pretty darn good for that day. Then we move into Montana. Even though Montana is a huge state, you've got a very, very tiny sliver. You probably fit about 2 or 3 people in there, okay? But Montana will be in the path of totality, you know? That's the cool thing. All right? Then we move into Wyoming. Exploratorium is going to be in 2 spots. We said Madras was the first one. They're also going to be in Casper, Wyoming. Casper is a beautiful. Everyone been to Casper, Wyoming? Yeah, Ron, who works with it in the back. Very beautiful spot. Ideal place to see the totality. However, if you want to pay $1,500 a room, good luck. I don't know, that's how much people are paying for rooms in Casper. Casper's been booked up for what, a year? 6 to 8 months, somewhere in there. Can't find a place. So good luck. Then we move into Nebraska. NASA Langley, our video crew here, will be traveling to Beatrice, Nebraska as part of the main NASA coverage. We have a number of subject matter experts that will be with them. They're going to be at a national park, broadcasting live. Again, Montana, Iowa's the same way. If you can blink, you've probably missed it. So you just have a very tiny little part of Iowa that's going to be in the path of totality. Then we move into Kansas, same way. Kansas, you've got the top northeast quadrant. And then this is where the fun begins for NASA Edge. We'll get into Missouri. You said some people are going to be in Missouri, Columbia, Missouri. Is that right? NASA Glenn Research Center will be in Jefferson City, Missouri. We'll have a contingency there. And then probably the best group will come next, which will be Illinois. That's us. We'll be in Carbondale. Now, the weather for Carbondale, that we talked to the local meteorologists out there when we conducted our site surveys. The clouds should not really be a factor. It's going to be the haze. So the haze is our concern, not so much the clouds. Knock on wood, August 21st, 2016, it was clear skies that day. So hopefully we'll get the same way. We'll talk more about our program here shortly. Then we go into Kentucky. We have NASA Marshall Space Flight Center will be in Hopkinsville. We'll have a contingent in there. The whole western part of the state, or pretty much the good part of the western part of the state, will see totality. And then we get into Tennessee. Now, Nashville is probably the largest in terms of population at around one location. Nashville is going to be packed with people in Tennessee. And then we get into North Carolina. If you live in the Great Smoky Mountains, that's going to be a pretty good place to see the eclipse. Now, if you have Wi-Fi capabilities, that might be a challenge being in the mountains, but we do have a team that's going to be there in the Great Smoky Mountains. And then Georgia, again, Georgia has just a small slither of totality. And then when we get into South Carolina, that's sort of the end for us, and that's where NASA headquarters is going to be. So the main NASA program will be based out of Charleston, South Carolina. They're going to be doing a 3-hour program. And at the very end of the program, the cool thing is they're going to be linking up to the ISS, and they're going to have some astronauts talking about the experience as well. And then as it moves off into the Atlantic Ocean, we're actually going to have, I think it's a Coast Guard vessel that's going to be out in the Atlantic, and there's going to be some NASA folks on the Coast Guard vessel as well, getting some final shots before we close the program. So this is a huge undertaking for the agency. A lot of resources are being pumped into this event. It doesn't happen every so often. At most, we get 2 total solar eclipses a year, not in the United States, but in the world here. And it's been, I think, 99 years or so since we had our last full total solar eclipse going across the country. But the cool thing about it is, if you miss it in 2017, if you get sick, or if you just forget about it, all right, don't fear, because in 2024 we're going to have another one that's going to be coming across the country. It's going to shoot from south to north. And the cool thing about where we're going to be in Carbondale, we call that the crossroads of the eclipse, because they're going to get the same eclipse in 2024. Imagine the astronomical value of that, trying to have 2 eclipses total solar eclipses in 7 years. Right? Now, what is a total solar eclipse? Now, I've got to say, I am not a heliophysicist. I'm not a scientist. So I don't want to answer that question, just out of respect for our colleagues at NASA Goddard. So what do we do as NASA Edge? We go video somebody. We go shoot an interview. We ask somebody what a total solar eclipse is. So let's check this out and see what Eric Christian, who's our senior research scientist, has to say. And by the way, he's going to be in Casper, Wyoming for the eclipse.
So Eric, tell us exactly what is a total solar eclipse?
So a total solar eclipse is when the moon moves between the Earth and the sun so that it completely blocks the light from the surface of the sun. And at that time, the Earth gets dark. You're in the shadow of the moon, and you can see the atmosphere of the sun, which normally you can't see, called the corona, streaming away from the sun. It's a really neat, in the middle of the day, you're seeing it dusk to dark on the ground. The animals react. It's just a really amazing situation.
Now, Eric, how common is it for someone in the United States to actually view a total solar eclipse?
So a total eclipse happens somewhere on the Earth at most twice a year. Most years only get one because of timing of where the moon is in its orbit. But somewhere on the planet, on the average of once a year, you get a total solar eclipse. But the shadow of the moon is actually pretty small. And so if you're just standing at one point on the Earth waiting for a total solar eclipse, it can be hundreds of years between when a total solar eclipse will happen. What's really neat about the 2017 solar eclipse is that even though the shadow is small, it goes right across the heart of the United States, from Oregon through south of St. Louis, all the way to South Carolina. And so even though it's only going to be a small part of the United States that sees the total solar eclipse, everyone in the United States is going to get at least a partial solar eclipse, and anyone who wants to can easily travel to the path of totality, to this line that the shadow takes across the United States.
What is the path of totality?
So the path of totality, there's a large region where the moon will only partially block the sun. We call that a partial solar eclipse. The region where the moon completely blocks the sun is pretty small, and that region moves at better than 1,000 miles an hour across the United States. So that's called the path of totality. That's where the path of the shadow of the moon moves as the total solar eclipse happens.
So Eric, there are satellites in space that study the sun. Why is it important for us to do it from the ground here on Earth?
So there's a couple reasons why. We have what are called coronagraphs, which make an artificial solar eclipse by putting a disk out in front of a telescope and camera to block the main light of the sun so you can see the corona, the atmosphere of the sun streaming away from the sun. We've been flying those for many years in space, but because for various physics reasons, because the disk is so close to the telescope, you can't get all the way down to the surface of the sun. You have to start further out. You have to block more than just the sun in order to see the corona. With a total solar eclipse, the moon is almost perfectly the size of the sun, and so you see the corona almost all the way down to the surface of the sun. And that's actually that narrow region that you can see in a total solar eclipse that you can't see from space is where all the action is happening. That's where the solar wind is accelerated. That's where the corona is heated. And so that's really exciting to see that deep corona in a total solar eclipse from the Earth that you can't see from space. The other thing that's useful about a total solar eclipse on the Earth is that it's a great way to test instruments that are studying the solar corona without the expense of launching them into space. And so you can actually point at the solar corona, look at it during the total solar eclipse. You've only got a couple minutes, and so it's a real rush job. But during those eclipses, you can test an instrument in a way that you can't until so you get a much better instrument that you can launch.
Now, scientists have been studying eclipses for forever. Mm-hmm. And what different information do they collect when they see an eclipse one year after the other?
So the sun is always changing. The sun is a variable star, and so that corona changes with time. The corona is millions of degrees, much hotter than the surface of the sun. And normally when you get further away from a heat source, you get colder. So the question of why the corona is so hot is one of the big scientific questions we have about the sun. And solar eclipses can help us with that.
Now, we just can't look up into the sky with our bare eyes. We need some protection. Tell us a little bit about what we need to actually view the solar eclipse.
So during the total solar eclipse, when the moon completely blocks the main light of the sun and you see the corona, you actually don't need glasses. That's one of the neat things about it. But any other time during partial solar eclipses, during things called annular solar eclipses, and during planetary transits, Mercury and Venus transits, you need to protect your eyes. You'll really hurt your retina if you just stare at the sun. Even if only a sliver of it, the sun is so bright that it only takes a teeny sliver to do some damage. So even though it may look dim because most of the sun is blocked, you still need glasses. And there'll be millions of these things across the United States, and you should put on your protective glasses, and then you'll still be able to see the sun. These things are completely black to everything except the really bright light, but you'll still be able to see the sun. You'll be able to see the crescent shape during the partial eclipse, and you'll be able to see annular eclipses with glasses like these. So you got to protect your eyes.
All right, so hundreds of years ago, imagine when you didn't have telescopes and you had the people looking up at the sky and you saw these eclipses. You can imagine what it was like, when the moon, passes between the Earth and the sun, daytime kind of turns to nighttime. You can imagine what a lot of these old civilizations were going through, and there were a lot of pretty interesting myths about eclipses back in the days. One is, the ancient Chinese thought there were invisible dragons in the sky devouring the sun. Or the Athenians of ancient Greece considered the eclipse to be caused by angry gods, so there were bad omens. American Indians believed that a squirrel was eating the moon back then. So there's a lot of interesting mythological stories about eclipses that if you have kids or younger brothers and sisters that you can read about, that's kind of interesting about eclipses back in the days. In Japan, they said wells were closed to prevent the sky poison hidden by the eclipse from falling into them. So there's a number of them that are out there. From the science side, as Dr. Eric Christian said, is that studying the lower corona is going to be the key. And so we're going to be having scientists that are going to be scattered throughout the path of totality with their telescopes, studying that lower corona during that 2-minute and 30-second, 2-minute 40-second time frame. It turns out that Arthur Eddington actually used a solar eclipse to confirm Einstein's theory of general relativity back in 1919. So even back in the 100 plus years ago, we were using crude scientific instruments to study eclipses and coming up with some very important discoveries. Now, one of the things that we're going to be doing for this particular eclipse is citizen science. And I'm sure you've all heard the term citizen science. And there's a group out there called Citizen Kate that is actually, I wouldn't say contracted, but has hundreds of volunteers throughout the path of totality where they're given a telescope for free. They're given a telescope. They're given some training on how to use that telescope. And they want them to collect data for this experiment. And Matt Penn, who is the director of Citizen Kate, will talk more about this particular program. And it's actually kind of interesting what they're going to be doing with the results of this. Check this out.
Now, Matt, you're working on a very cool project for the eclipse called Citizen Kate. Tell me all about it.
Right, so the Citizen Continental America Telescopic Eclipse Experiment, or Citizen Kate experiment for short, involves a network of telescopes across the country. And we're going to have a spectacular eclipse coming across the country, but at any one site, you can only see the corona during totality for maybe 2 minutes. What we'd like to do is to study the corona for a much longer period of time. And by stringing together a network of sites and merging that data, we'll be able to make a movie 90 minutes long showing the corona.
So you guys are making a film kind of like Orson Welles with Citizen Kane. You're Citizen Kate.
Rosebud, Missouri is actually a town that's in the path of totality. So in the park in Rosebud, Missouri, at around noon, people will see the corona for about 2.5 minutes. It's an opportunity to name the program and have several different twists that work really well.
Is your movie going to be in black and white? Because I love black and white.
Yes, it will be in black and white. We have monochrome cameras.
Now, how are you going to get these observations all along the path of totality?
Right, it's going to be a challenge. Certainly we don't have enough solar physicists in the country to man these locations with scientists. So we're reaching out to volunteers, people who do amateur astronomy as a hobby, or people in school who like astronomy, or teachers, with the added bonus that the idea is we'll give them the telescope and the equipment after the eclipse. So the eclipse is something that they'll participate in, it's cutting edge research, and then afterwards they can take the telescope home and continue with astronomy research at night.
Now, are you obligating them to provide data for the rest of their lives? If you give them a telescope, then they've got to report into you, or is this really just one of those inspirational things?
You know, speaking with the people here at the meeting, you understand that they're just driven. They're motivated. This is their passion, to look at the skies. And so I'm not really going to have to, encourage them or make them sign a contract. These are people who are going to go out and use the telescope at night just because they love to do it. So I think this is the best way to deal with the resources of the telescope after the eclipse.
Now, would this only apply to amateur scientists that are in the path, or would anybody be available if they could travel?
Oh yeah, so we have across the country about 100 or 150 people volunteering who have hotel reservations and are going to be at the eclipse and just want to be involved in the project to take data. Another benefit is that the data that will be collected will be used for cutting edge science, and those people will be involved in the publications and they'll be cited, their contributions will be cited properly.
So if I were able to participate in this program and I collected some observations and data and you used it scientifically, would I be able to receive an honorary doctorate in some kind? Because I'm really looking to get into the scientific community.
If I had my own university and could do that, I would certainly give you a degree. But people will be acknowledged in a respectable way in the publications and the research that comes out, yes.
Thinking of this movie that you're going to construct with this data, you have to train these people to actually capture the data well. How do you do that?
Yeah, there are some things that are a little bit complicated. First, setting up the telescope is going to be a little time consuming. And then we have about an hour's worth of calibration data before the eclipse, where people have to be following, we hope, a pretty simple script to take the calibration data, to turn the data just from pictures into real science quality data. So we're going to have some training sessions, and right now we're working with 4 student groups at different universities and training them to become the trainers for the 2017 event.
Now, if this is successful, do you anticipate replicating this program and perhaps taking an additional step in, say, 2024?
Yes. The interesting thing about this is it could also be a test case for the 2024 eclipse. That eclipse has a longer duration, which means we can collect more scientific data. And it's also exciting because it involves the entire North American continent. So we can go from Mexico through the United States and Canada. It'll be a real international affair. And we're looking forward to having another project building on what we learned from 2017.
So it's kind of a global citizenship for Citizen Kate in 2024.
Exactly. There are many programs. Astronomers Without Borders is one of those programs that does astronomy around the globe. And a total solar eclipse doesn't care what country it crosses. It's going to cross the Earth. It's a nice way to unite people from different countries and have a shared experience with the sun and the moon.
So the cool thing about that is, if you miss out in 2017, you got 7 years from now, you can be a part of that. And Matt Penn's a really cool guy, and I can't say enough about that Citizen Kate project. When we were out in Carbondale to meet with Matt and the team, it's very I wouldn't say simplistic, but it's very straightforward in terms of the training, how to use the telescopes, the process that you're going to have to go through. And it doesn't take a rocket scientist to be able to pull this off. I mean, we can get amateur astronomers, or even anybody who has just a love for astronomy or a passion for astronomy is really worth it. Viewing the sun, as Dr. Eric Christian said, you can't see the sun unless it's complete totality. You just take off your glasses, you can see the corona. So what are some ways that you can actually observe this eclipse, especially the partial eclipse? Well, one way is to use a pinhole projector. Has anyone ever made a pinhole projector before? So some of you are familiar with it. Very simple, very cheap. It doesn't cost a lot of money. So that's one way, especially if you have kids or you have younger brothers and sisters, or you're going to be at schools talking with students. This is a great way to get the kids excited about eclipses. What's that? You do need a little practice, yes.
Yes. Otherwise, I set up. Gotta follow the sun. Get it in there.
Right.
You have to line everything up.
It's just like anything else. What I was going to do today, I'm going to show you a piece of technology at the end that I've never done in the audience before. So I'm going to break the mold and see if it works. You're right. Please test it out before you do it. Another one is I've never done this before, but use a projector using binoculars onto a sheet of paper. Bert, you have experience with that? Imagery, very good. Yes. Right. Right. Of course, another one, the cheapest way is to use those viewing glasses, and then when you leave today, you will have your own personal pair of eclipse shades when you leave, so that you can use it for the event come August 21st. Another way is using Welder's number 14 glasses. That also works. Bird, he actually has a nice contraption in the back that he's put together, where you put a set of goggles over your head, and it's a pair of 14 Welder's glasses. So after the presentation, feel free to walk by and check it out. Of course, an ideal way is to use a solar telescope. We have a couple of solar telescopes up here. This telescope here is a Lunt from Lunt Solar Systems. This is the exact telescope that was used during the Venus transit in 2012, when we were on top of Mauna Kea doing a 7-hour broadcast. This telescope was hooked up to a red 5K camera. We were broadcasting for 7 hours, so this is sort of historic here. And then we have one of Bird's Coronado's, it was a PST solar telescope. And if it's clear outside, we may be able to take it out afterwards if you want to see the sun. Another piece of technology that's come out in the last year are called sinoculars. They're just regular binoculars designed for looking at the sun. This is a pair of Lunt Solar sinoculars. It's very cool. They have, I think, an 8-power magnification. I've got one in my office. If you look through it, I mean, you can see the disk of the sun. Or if you have some money, you can get some of these pretty much bigger telescopes, which we'll talk about here shortly. That's Dr. Lou Mayo from NASA Guided, by the way. He's going to be with us in Carbondale. Okay. So as I said before, NASA headquarters is going to be in charge of the main program on the day of the eclipse. So they're going to be based in Charleston, South Carolina. They're going to be doing a 3-hour program. I think it starts at 1 o'clock Eastern time. We're going to be in Carbondale. So the plan for NASA TV is that when they start their show, they're going to start from the West Coast, and they're going to work their way to the East Coast. And so they're going to be going to Ames. They're going to be going to JPL. They're going to be going to Langley, to Glenn, and they're going to come to us for 5-7 minutes, and they're going to go all the way to the East Coast. What we plan on doing, we're going to be doing a 4.5-hour broadcast from Southern Illinois University in Carbondale, the home of the Salukis. Anyone graduates? There you go. Oh, there you got the email. There we go. So at the home of the Salukis, and I got to tell you, they have just opened the doors for us for this event. We've been there a couple times doing site surveys, and it's a wonderful university. The facilities are excellent. It's an ESPN3 school, so they got all the bandwidth, all the technology that's needed for us to pull this off. As I said before, this is going to be the largest event that we've ever done. And before we actually get into the technical part of it, to kind of give you an idea of what our show is going to be about, let's hear what Bob Baer. Bob Baer works for Southern Illinois University. He works in the physics department. And this will kind of give you an idea of all the activities that are going to go on at SIU before the eclipse. So Bob, you're one of many cities along the path of totality that's going to be covering the eclipse. What is Southern Illinois University going to be bringing to the table?
So quite a bit. This is a really large area here in Southern Illinois, and the university is about 6 to 7 miles from the point of greatest duration. We're setting up a lot of different venues here. We've got venues that will be open to the public leading up to and the day of the eclipse. We're going to try to enhance people's experience when they come here.
Now, we're expecting millions of people, not just in the United States, but from around the world to be flocking along the path of totality, from Oregon all the way down to Charleston. How are you going to deal with all these crowds coming to Carbondale?
That's a really good question. So what we've been doing in our planning is we've been planning for what we think we can handle on campus. We're working with the city. The city's doing some of their own planning as well, but we're trying to tie it together so that it works well. But give the people who are coming here a place to go. Let them, in some cases, reserve tickets for some of the venues so that they know that they have a spot. We're working with the hotels through the area, and as well as with the state property, the parks, the state forest, the national forests. There's a lot of people from those organizations today to take part in planning.
Are you going to offer programs for your students to be able to do any scientific research with the eclipse next year?
The main one here is the Citizen Kate experiment.
Okay.
And that one, as you can see, we have one of the telescopes here today from that. We got involved in that a couple years ago while it was still being formed somewhat. I was working with Matt Penn, who's the PI of that project, and I went with one student from SIU to Indonesia. I went with a physics undergraduate named Sarah Kovac.
Okay.
And Sarah's leading a good-sized group of students here. They'll be doing a workshop here at this conference tomorrow and continuing this through this eclipse as well as beyond, we hope.
Now, you were over in Indonesia to view the last eclipse, which was back in March of this year?
March 9th, 2016, yep.
So what are some tips that you can give to the general public who may want to see the eclipse, or if they're outside the path of totality to see the partial eclipse, that may help them out?
So the eclipse is big. That was one of the things I didn't understand. When I saw it in the sky, it was a lot larger than I expected. You've got this full moon and you've got a corona, and that corona looked to be about twice the diameter of the sun. Wow. So you don't need a telescope to see that. You can see a full moon naked eye, and you can see that corona naked eye, and that's the only way you can see the corona. There's a sunset effect that you get 360 degrees around you, so if you have some open space anywhere around you, you can see that sunset. If you have a lot of open space, if you're up on a high elevation, the sunset's all around you. And that sunset, those colors fade in and fade out. For people who are nature lovers, you've got all these cool sounds coming in, like the frogs, the crickets, all the animals that come awake at night come awake during an eclipse. And it gets pretty loud. In Indonesia, that got very loud where we were at. We had tropical birds just going crazy around us. And then depending on the place you're in, like for Carbondale, we're gonna have the crowds here. I'm really excited to see this with a large amount of people, to hear the roar of the crowd, to see the reactions of the people. The partials, eclipse glasses are great, projection methods are great, and as you get close to totality, those high percentage partials, like say a 90% partial, when that light comes down through the trees or through a hole, like a pinhole, or even you can hold out your hands and you can see the diffraction patterns on the ground. You can see little shapes of the eclipse on the ground as you get to 90% and above. Wow. So there's lots of cool things kids can do during the partial as long as they're supervised. If I had some advice for people who are going to take pictures of the partials with proper filters. That's great. That's a lot of fun. You've got like an hour to do that in. But once totality hits, you really need to be looking at totality and just enjoying it.
Pretty cool, isn't it? Now, so for the big show, this is going to be kind of cool. So technology has changed a lot since 2012. So when we were in Mauna Kea for the Venus Transit, having a 7-hour broadcast, we had 3 different telescopes. We had hydrogen alpha, calcium K, and white light. And we're going to have the same 3 sets for this event as well. However, the best resolution that we were able to broadcast live to the world was this picture right here. That's what we had. For this event, this is what you're going to be seeing from our telescopes and from our video camera. Pretty impressive. And this is video here. So if I play this, so this is a Lunt solar telescope attached to a red 6K camera. I mean, the resolution is pretty incredible, isn't it? And that's just video. We're also going to be providing process imagery as well, and it's going to be real-time process imagery. So we're going to be showing the video, like you see here, And then when you see the process imagery, it's going to be even more detailed. They're going to be 6K and 8K pictures that we'll be broadcasting live during the event. And this is the type of telescope that we're going to be using for each wavelength, for hydrogen alpha, calcium K, and white light, attached to a red camera. And the way we're going to do it for this event, we're partnering with Luntz Solar Systems, and they're building what he calls a Sun Lab. It's a 10 by 20 container, enclosed container. The telescopes will be inside in a horizontal position. He's got a 20-inch heliostat on the outside of the container. It's going to take the rays. The heliostat is going to direct the rays into the container, and that's where we're going to get our imagery. And inside, it's going to be air conditioned, and they're going to have 2 or 3 people inside working the laptops, getting the video down. We'll get the video live for our feed, but then during that time, they're going to be processing all that video and making even super high quality 10 to 20 second animations for the public. Not just for the public and for everybody, but the news stations, the Weather Channel it's coming out to Carbondale. They're going to be using our feeds. So these 3 telescope feeds are going to be, if knock on wood, it's clear that day, and we get the video, it's going to be used worldwide. So, okay, who watches college football? Raise your hand. Who's ever seen a college game day show on Saturday before kickoff? Pretty excited. It's a pretty cool show, isn't it? They got you're at a college campus. You've got the stage. You've got the host. You've got the students in the background. You've got the signs hanging up. They got all these different pieces. Well, this is what our megacast is going to be. This is what we want to do. We're calling it the Total Solar Eclipse Megacast. I took that from the page. So this is what we're hoping to see on the day of the eclipse. So for our show, we're going to have 3 different areas for hosts. We're going to have a main stage. We're going to have a science demonstration area right behind the main stage in this area. And then we're going to have a host inside the football stadium, because there's going to be tons of events going on inside the stadium as well. So we're going to have 14 different feeds. This production is even going to be bigger than what NASA headquarters is doing in Charleston. This is the largest production from any group for the eclipse. We're going to have 4 main stage cameras. We have the co-host is in the back, Blair Allen, who's going to be on the show. He's back there. He's the goofy one that was making all the jokes earlier with Matt Penn. We're going to have a camera in the science demo area. Franklin, who you saw interviewing Eric Christian, he's going to be in the science demonstration area during the show. We're going to have an SIU co-host, Southern Illinois University co-host, inside the stadium with a remote camera. We're going to have a press box camera, which is going to be a wide view on top of the press box of the football stadium. We have the 3 telescope feeds, as I said, hydrogen alpha, calcium K, and white light, providing stunning imagery for that full 4.5 hours. In fact, Luntz Solar Systems will be arriving in Southern Illinois University 2 weeks before the event, so they can calibrate all their instruments and their telescopes. And so by the time we get there, everything's going to be ready to go. We're also going to have a process imagery feed, as I mentioned, where they're going to be bringing us stunning pictures, 6K and 8K pictures, and also animation from that video feed. And then another cool thing that I haven't even talked about yet is that Space Grant is going to be having a number of balloon launches along the path of totality. They're going to be launching weather balloons. And so we get one at our university. LSU is going to be bringing their balloon down. They're going to be launching from the 50-yard line from the football stadium. And they're going to have a camera mounted so that when it gets to about 80,000 feet, hopefully, if the weather's clear, we're going to be able to see the shadow on the Earth from the moon. So we'll hopefully bring that live as well. So that's a balloon feed. And then social media feed, we're going to be on social media like crazy. So if you're on the Facebooks or the Twitters and all those places, please follow us, because we're going to be streaming on Ustream, Facebook Live, and YouTube all at the same time. Those are our 3 methods. And since we're at a college university as well, we're teaming up with WSIU, which is the local PBS station. They're bringing a satellite truck in, and they're going to uplink our broadcast to any PBS station that wants to take it around the country. So hopefully PBS stations will air that program live as well. So it's going to be an astronomical event, not just in terms of the event itself, but for us as a production crew. We've never done something this large before. There's so much we've done up to this point, but there's so much that we're going to be doing. The content is going to be filled with subject matter experts, science demonstrations. We have local meteorologists going to be on the show. The Weather Channel, I just got a call from the Weather Channel the other day from the Vice President. They're sending a crew. I told them to send Jim Cantori from the Weather Channel if we have first dibs. So he's agreed that we can interview whoever the personality is going to be on our show. And even though this is the big event, there's going to be so many activities at SIU leading up to it that we'll be covering through Facebook Live. We have a nice fireworks display. We have talks. We have symposiums. So there's going to be a number of short Facebook Lives that we'll be doing leading up to the big show. Any questions so far? I'm almost done. So once again, I invite you August 21st. If you're not in the path to totality, if you can't make it there, and if you want to watch the program, give us a shot. You don't have to watch all 4.5 hours, which would be nice if you did, but you don't have to. Just I think what's going to be the attraction for most people is going to be the stunning views from the telescopes. Because there's as far as I know, besides the NASA satellites that are going to be tracking it and taking pictures, in terms of from a NASA standpoint, telescopes that we're going to be offering that Lunt's building for us are just going to be spectacular. And so if we can get clear skies and the haze is down a little bit, it's going to be gold. But it's sort of like the same thing for us for transit. When we were in Hawaii, the day before the transit of Venus, they were calling for snow up on top of Mauna Kea the next day. We were struggling. I mean, Blair can tell you, we were sitting there at 9,000 feet in the lodge, and we were trying to figure out what are we going to do next day. We're supposed to be broadcasting this huge event for NASA. We got the transit of Venus. The next one's not going to happen for another 107 years, and they're calling for snow. Talk about a huge, morale factor. We woke up the next morning. We looked up on the mountain. It was clear as can be. For all 7 hours of the broadcast, it didn't start getting cloudy until we finished our broadcast. So we're gonna pray and see if we can get some luck for this event as well. All right. So here's the website. If you want to learn all about the eclipse, it's eclipse2017.nasa.gov. I highly encourage you to go there. They've got a number of downloads, a ton of shareables. They've got some cool posters. Bird made a hard copy for it. I have some in my office if you want some. They have some very good tips on how to, how to view the eclipse, all about the eclipses, what are they about, even has eclipses for the future. Where's going to be the next eclipse after 2017. So it's a great way to learn about that. Before you go today, I encourage you to take one of these cards. It's a sort of just a business card, but it has all the social media feeds that NASA is going to be using on the day of the eclipse. So take that and put that into your phone. And then, like I said before, each one of you will get your own eclipse shade. So please take one. If I have more after everyone has one, then come back around and I can give some more as well. That's not a problem. Any questions? Yes. That's a great question. That's all about celestial mechanics and orbital mechanics, and the folks at Goddard. Before the eclipse, about a year ago or so, is when the first map started coming out in terms of where the path was going to be, and so they had that pinpoint down to, I would say, the nearest mile. I mean, nearest half mile or maybe even foot. I mean, it's pretty accurate. And they go by, and when they were designing the maps for this, I mean, if you go on, I think it's on the 2017 website, they have a super high-res map that is, I want to say it's like maybe 80 megs, somewhere in there, and it's really detailed, so you can really hone in and see exactly where that line's going to be in each of the states. Right. Yes. Okay, so SIU, so our path of totality is going to be, it starts at 1:20. That's Central Daylight Time, so 2:20 Eastern Daylight Time. And ours is 2 minutes and 40 seconds. So I think the greatest duration, which is about 6 miles south of us in Makanda, Illinois, is 2 minutes and 44, I believe. In fact, in Makanda, this is kind of interesting. So Makanda is a small town. And so you've been to Makanda when you were there? Okay, so Makanda is a small town, and literally, you can see this on the news, that there's one shop, and the guy painted an orange line, which is the center point of totality, across the street into his shop, all the way into the wall. So it's gold, because he's going to have thousands of people coming to his shop. I mean, he's already had tons this summer, but leading up to that event, everyone's going to want to take a picture of them on that orange line, before the event, which is going to be kind of cool. Now, there are some issues, though, with the eclipse. One is traffic. Traffic's going to be a nightmare if you're in the path of totality. They're expecting, millions of people, especially if you're going to be in the Charleston area, the Nashville area, the major cities. Traffic's going to be a nightmare. Hotel rooms. You can't, if you haven't booked a hotel room yet, forget about it. Or you're going to be paying $400, $500, $600 a night. I know this true story. So we're in Carbondale last year, staying at the Hampton Inn, and so we booked our hotels right away a year out. We talked to the manager, getting government rate, and then all of a sudden they realize, oh, there's an eclipse coming to town. As soon as they realized that eclipse was coming to town, that rooms went from $79 a night, which is the government rate, to $399 a night. It's pretty amazing. And so everyone who's along that path, I mean, hotels are going to do very well that day. And I said Casper, they were charging upwards of $1,500 a night for places, and trying to make out on that. So traffic's going to be rough. Lodging's going to be rough. There are flights now. I just saw an article in USA Today that I think it's Alaskan Airlines is going to be offering eclipse flights, where you can fly on their plane and view totality while in the skies. In fact, one of the guys we're working with, Mike Kintrianakis, who is he works for the American Astronomical Society. He's the project manager for the eclipse. He was actually on a flight. When was it, Blair? Was it the last eclipse, or maybe last year? He was on a flight on the eclipse and actually took photographs from the plane, which was kind of cool. Another issue is going to be general aviation. Are the skies going to be an issue that day? Because everyone's going to want to go up on their planes and get in the path and view the sun. So that's going to be an issue. What are commercial airline flights going to do that day during that time? Because the eclipse itself, from Oregon to Charleston, is about an hour and a half for totality. Now, the partials are going to be much longer, but totality itself is about an hour and a half. So within that time frame, what's going to happen with the skies? So it's even though it's a wonderful astronomical event, it happens once in a lifetime, and it's going to be great. There are some concerns that you're going to have to deal with, like Southern Illinois University. What happens if you have over 100,000 people flock to the university? How are you going to control that? Do you have enough police? Do you have enough emergency services? Do you have enough sources to provide for those people? And that's just Carbondale. What happens in Charleston when you're along 95 and you may have hundreds of thousands of people in Charleston or Nashville? So it could be a logistics nightmare for a lot of these cities. But anyway, it's still going to be pretty cool. So this is a good test for the 2024 eclipse. So they'll be ready 7 years from now. Any other questions? Yes. We know we tried to, we thought about this as an idea. We were going to see if Langley, if we could take an F-22, and if you fly just over 1,000 miles an hour along the path of totality, and if you could have enough fuel, they would see totality the entire time for an hour and a half. It would be in complete darkness, which would be kind of cool. But I don't think they never responded. So, yeah. But it was a good idea, though. Yeah. Any other questions? Well, thank you so much for coming by. Again, eclipse2017.nasa.gov. And then what's your homework assignment by next Monday? You got to download all 150 plus episodes from our website or iTunes. Or just subscribe to iTunes and it'll automatically download and just leave your computer running and go get a coffee or something. Okay? Thank you. Have a good one.